Good morning to everyone. Today I discuss the topic on FM demodulator. Demodulator means recover the original signal. So FM demodulator means recover the original signal from modulated wave. Here the modulated wave is the FM wave. So recover the original signal from the modulated wave is called the FM demodulator. There are different types of FM demodulator. Okay, there are different types. So I classified the FM demodulator. First is slope detector. Okay, and second is phase difference detector. First is the slope detector and second is the phase difference detector. Okay, there are two types of slope detector. Okay, is called the simple slope detector, simple slope detector, and another is balance slope detector. Okay, and phase difference detector are two types. Okay, first is FOSTER-SELEY discriminator. Okay, and second is ratio detector. In previous lecture I discussed the slope detector, okay, and which is the simple slope detector. Today I discuss the phase difference detector, which is FOSTER-SELEY discriminator. Okay, today I discuss the FOSTER-SELEY discriminator. FOSTER-SELEY discriminator. Okay, this is the FOSTER-SELEY discriminator. This is the circuit diagram of FOSTER-SELEY discriminator circuit, which is a FM demodulator or FM detection method, and this type of detector is mostly used. Okay, this type of detector means a FOSTER-SELEY discriminator is mostly used for detection of FM signal or recover the original message signal from a FM wave. So in the circuit we show that there is a transistor. First there is a transistor, and this is the primary winding, means here the primary tuned circuit. This is the primary tuned circuit. This is a tuned circuit, and this is also a tuned circuit, and it is called the secondary tuned circuit. This is the primary tuned circuit, and here the secondary tuned circuit. So in the FOSTER-SELEY discriminator, double tuned circuit is used. Okay, double tuned circuit, primary tuned circuit and secondary tuned circuit. So the double tuned circuit is used, and here a capacitor C is used between primary tuned circuit and secondary tuned circuit. Capacitor C is used between primary tuned circuit and secondary tuned circuit. Here also a diode is used, D1 and D2. So we know that in FM demodulator, first the FM signal converted into AM signal, and then AM signal, from this AM signal we recover the original message signal. So here the FM signal, here the incoming FM signal, first the transistor is amplified, the FM signal. Okay, then FM signal is passes through a single tune circuit, which tune circuit consists of L and C, and a voltage is developed across a single tune circuit, which is V3. When FM signal is passing through this primary tune circuit, a voltage is induced, and this voltage is denoted by V3. Okay, so this is the second tune circuit, and this first tune circuit, second tune circuit, and this circuit is AM detection. This circuit is the AM detection. This is the AM detection circuit. Okay, AM detection circuit. So here this capacitor is used for two purposes. This capacitor is used for two purposes. First, it blocks the DC component. It blocks the DC component and passes only AC component. Okay, it blocks this capacitor. The function of this capacitor is it blocks the DC component and passes the AC component. And second is the function of this capacitor. This capacitor is the second is it used as a coupling network. Okay, it used as a coupling network because it couples the signal from primary to secondary. It couples the signal, this primary signal and secondary signal, and this capacitor is coupled. This capacitor is coupled between primary signal and secondary signal. So it acts as a coupling network. So this V3 appears, which appears in primary side, is appears in secondary sides due to mutual inductance. So the equal voltage drop developed across V1 and V2. Okay, V1 and V2, but in opposite in polarity. Okay, so center trapping of secondary coil has equal and opposite voltage. Equal means V1 and V2 is equal in magnitude, but phase is difference, because this is the positive and this is the negative, and this is the positive and this is the negative. Okay, so equal in magnitude but opposite in phase. Okay, so it's act as a half winding. Okay, so V1 and V2 equal in magnitude but opposite in phase. Next term, V1 and V2 equal in phase but so opposite, equal in magnitude, so equal in magnitude but opposite in phase. Which is V1 and V2. This is the secondary winding voltage. Okay, secondary winding voltage. V1 is across the diode D1 and V2 across the diode D2. So the input of diode D1 is the VA1, is denoted by VA1, which is the input of diode D1, which is V3 plus V1. V3 is appears to the secondary winding, and there is a secondary voltage V1. So this voltage is appears across these diodes. So VA1 is equal to V3 plus V1, and VA2 is equal to V3 minus V2, because V1 and V2 equal in magnitude but opposite in phase. Okay, so this is minus sign is indicate opposite in phase. Okay, so the result of the output voltage V0 is the output voltage, this voltage is V0, so it is the differences between diode D1 and D2. Okay, so it is denoted by V02 minus of V01. Okay, the output of the diode D1 is V01 and the output of the diode is V02, and this is a center trap transformer. The equal voltage is developed across this diode, so output voltage is V0 is equal to V02 minus of V01. So here there are three conditions available in these circuits. Here three conditions. First condition is at resonance condition. At resonance condition. Resonance condition. Okay, at resonance condition. When the input voltage has a frequency equal to the resonance frequency. Okay, means V3 is generated in primary winding. V3 is generated in primary winding. Okay, with and is goes to the secondary winding, which is V1 and V2. So V3 is in phase with V1 and V2. At resonance, V3 is phase with V1 and V2. Okay, V3 is primary voltage and V1 and V2 is secondary voltage. So V3 is goes to the secondary side. So when V3 goes to the secondary side, V3 in phase with V1 and V2 means V1 and V2, V1, V2 and V3 same phase. Okay, is called the at resonance condition. So at the resonance condition, the figure is, okay, the diagram is this is the V3 appears in primary side, and this is the secondary side V1 and V2 and equal voltage. So this is the equal voltage. Okay, this is the VA1 and this is the VA2. Okay, so equal voltage is developed. Equal voltage, V1 is same, V1 and V2 is same, but same magnitude but opposite in phase. This is the at resonance condition. And second is off resonance condition. Off resonance condition. What is the off resonance condition? Means V3 is out of phase with V1 and V2. Okay, this is called the off resonance condition. So out of phase means 90-degree phase shift. 90-degree phase. Okay, out of phase means here the 90-degree phase. So here if V1 greater than V2, here V1 is equal to V2. V1 and V2 is same. But if we consider V1 greater than V2, the figure is V1 greater than V2. Okay, so this is the V1 and this is the V2. V1 greater than V2. Okay, this means this is the phase differences. Okay, this is the V3 and this is the V1 and this is the V2. So V1 is larger than V2. Okay, so VA1 is large and VA2 is small compared to VA1. And here also consider V1 less than V2. So this, okay, this is the V2 and this is the V1. So from the figure we see that V1 is small and V2 is large. So this is the VA1 and this is the VA2. So VA1 is small because this is the small voltage is developed across the V1 and a large voltage is appears across the V2. But in frequency discriminator circuit, always maintain and at resonance condition, means V1 is equal to V2, means equal voltage is induced in secondary winding equal voltage is induced in secondary winding at resonant condition. We maintain the at resonant condition. So at resonant conditions, so here the V1 is equal to V2 means equal in magnitude but opposite in pole, means opposite in polarity. So this appears the input of diode D1 is denoted by VA1 and input of the diode D2 is called the V of A2, which is this value. So output of the diode V1 is denoted by V01 and this is the output of the diode D2 is called the V02, and there is a separating network. It's separating network, okay. It is a separating network, and this capacitor is also used for it passes the AC component and block the DC component, okay. So only AC component goes to the output, and there the output is the difference between the two diodes output. So V02, we consider V02 is higher and V01 is lower, so output V0 is equal to V01 minus of V02, which is the message signal, and this is the message signal. So in FM demodulator or in FOSTER-SELEY discriminator method, the FM signal converted into AM signal, and this is the AM detector. So in the AM detector, AM signal is removed and original message signal is produced. So this is the FOSTER-SELEY discriminator circuit we considered, and this circuit is mostly used in FM detection. This is the mostly used in FM detection, and it is used in our TV or radio FM detection circuit. FOSTER-SELEY discriminator circuit is used, okay. And this is the circuit diagram and principal operation or working principle of FOSTER-SELEY discriminator circuit, okay.